Buckling is for sure a dangerous phenomenon likely to happen when a thin structure is subjected to compressive loads. The structure exhibits unstable behavior and a brutal change of configuration, compromising the safety of the component. It's so severe that safety assessment of aircrafts and other thin structures requires this type of analysis. Linear buckling is the first way to predict buckling loads and modes. So let's apply it first to our example. Here is the stiffness panel we consider in this demo, already imported and meshed in Simcenter 3D. After applying the proper boundary conditions, we select Simcenter Nastran, a finite element solver of Simcenter 3D, and we calculate the different buckling modes and corresponding buckling loads. We can go through the different modes and check for which load they are likely to happen. However, only nonlinear analysis is capable to reproduce the whole buckling scenario and predict the load-carrying capacities of the structure in the post-buckling configuration. So, let us now restart an analysis by selecting the Simcenter Nastran Solve 401, nonlinear multi-step solution of Simcenter 3D. Classical nonlinear solver may experience numerical difficulties when calculating buckling scenario due to instability and lack of stiffness. In Simcenter Nastran Solve 401, specialized algorithms like arc-length methods will go through the whole load history, tracking the structure's nonlinear behavior up to post-buckling and limit load. The main reason buckling is following a given path rather than another is the existence of geometric imperfection. A proper way to take into account such imperfection in the simulation is to use a mode shape, specifically the one reproducing the right imperfection. This is exactly the scenario we are going through in the second part of the demo. The goal will be to reproduce a precise buckling and post-buckling scenario of our stiffness panel. We'll start with modal analysis, so to examine the modes and select the right one to be used as geometrical imperfection in the nonlinear analysis. So, as a second step, we'll restart Simcenter Nastran Solve 401 and select the proper mode as geometrical imperfection. We run the post-buckling analysis again and end up with a slightly different path compared to the one calculated without considering any geometrical imperfection. The result of the simulation accurately reproduces reality, allowing the engineer to easily compare different buckling scenarios and finally spare a lot of time and money, just replacing costly real testing by accurate virtual twins. Additional advantage is the capability to easily modify the design and optimize load-carrying capacity of the structure with respect to real-life conditions.